Hello and welcome to episode 5 of my introduction to tabular programming for SPLat. In this little episode I'm going to describe to you the else event. Else is an event which is always true. So what that means is that if there is a transition specified for else in a particular state, it is always going to take place, but it is the last thing evaluated. Even though it appears near the top of the column, it's the very last thing evaluated. So in absence of any of the specifically specified events, this will take place. I'm going to illustrate that to you by extending our stairwell light switch system with another little feature, and that feature is going to be that when the light is about to turn off, it will optionally give the user a warning by flickering off briefly and then coming back on for a fixed period of time. Now, just to spice it up a little bit, what I'm going to do is I'm going to make this option or this feature optional. So it will actually only be executed if input 4 is switched on. By doing that, we give the owner of the building the option to have this feature present or not. So and that's where the else event is going to come in. So what I'm going to do is I'm going to set up a condition here, an event, which specifies that input 4 is on. So that's very simple. We'll call that warn mode, and the condition for warn mode to take place is that input 4 is on, like that. You notice I'm not bothering with a symbolic name this time because I just want to get through this. So there we have warning mode will take place if input 4 is on. Now, to implement warning mode, I'm going to need at least two states, one for the light off and one for the light on. But I'm also going to have a third additional state, which is going to be the one where we actually decide whether to invoke the warning mode or not. To create that transition state, that decision state, I'm going to actually insert a state ahead of state 4 just to make it a touch more interesting. I right-clicked on the header for 4, click on insert state, and you notice that what was in 4 has now become state 5, and the references to that state have been updated. So I can insert and delete columns to my heart's content, and any adjustments, any references to the moved columns will be corrected. Now in this case, I want this particular transition here, which is the button being pressed while the light is on. I want that to go to state 5 still, but these other two are the timeouts, and I actually want those to go to the new state 4. So I'll just change those to state 4. Now in state 4, what I'm going to do, I'm not going to take any actions, I'm merely going to make a simple decision. And that is, if the warn mode input is on, the input 4 is on, I'm going to go over to state 6 over here, which I've yet to fill in, and do the warning thing. So make that 6. If that's not on, else, in other words, I'm just going to go to state 5 and continue the sequence as it was before we added this feature. Now in state 6, all I have to do is turn the light off. I don't even have to give it a name anymore. I've changed the program. Tabula's been changed since you last saw it, so the names are no longer necessary. Turn off output LED, start a timeout, make it a constant, let's say 2 units of time, and then when that's finished we go to state 7. In state 7 we don't need a name again, we turn on the LED like that, and we start a timer. Now let's start the timer. I could have done that while I had that window open. Start on entry, time limit 10 units of time, like so. Now you'll notice something else that's been happening while I've been doing this. The warnings area in the code generation window, which I have kept open, is updating itself dynamically. So right at the moment it's telling us that state 7 has a timing mode specified but no timeout transition, and indeed this cell here, the timeout transition, is empty, and state 7 is a dead end. I can get into state 7, but as it stands I can never get out of it again. So let's fix that up. put in the transition here, which is going to be to state 5. Because at state 5, when I go over there, I turn the light off, I ensure that the button is released, and then I go back to the beginning, and now we're good to go for the next cycle of the system. So there you have it. We can take a look at the code here. Of particular interest is possibly state 4. There we go. In state 4, we do nothing on entry. We check 4. If it's true, we go to set 6. If it's otherwise, we go to set 5, which happens to be the next line. And you'll notice there is no loop and no yield, because state 4 is actually just a transitory state. We come through there, make the decision, and pass on. So really, state 4 is somewhat equivalent to a decision diamond shape in a conventional flowchart. And of course, in this case, we could have multiple choices here with one final default or else clause at the end. So that's it, the else clause. It's actually very powerful. It allows you to make decisions basically on the fly between states. And as far as I know, it's somewhat unique to the way that we do finite state machines here at SPLat. Thank you for listening.